This is going to be our last lesson on integrals, and we are talking now about the area between two curves. And so far we've done like the area between a curve and the x-axis, and now we're going to talk about what would happen if we had two curves and we wanted that area between them. So this is write the integral notation and evaluate the area between this curve and this one. So a normal parabola and a line, just basic x line. And then we're going to go from 2 to 3. So what we're talking about, just to give this a quick sketch so we kind of have a feel for what's going on here. We've got this parabola and we've got this line. That line is just going up 1 over 1, up 1 over 1 the whole time, and so it just looks something like this. So that is the line x. Then we've also got this parabola, and it's going to be a little bit steeper because the times 2 is going to make it a skinnier thing. So if I plug in a 1, I actually get a 2. If I plug in a 2, I would get 2 squared is 4, 4 times 2 is 8. So it's going to get pretty big pretty fast. So what's happening is I have this sweet parabola just like that. From 2 to 3, so from right there to right there, and imagine that we can see that going all the way up to the top, we want to find the area between the two of them. So I'm talking about all that area between the two curves going from 2 to 3. So what we first have to do is figure out which equation is on top, and what we're going to do is take that one and all of its area all the way down to the x-axis, and then we're going to subtract off this one, which would be just its area under the x-axis. So if I take the whole thing and subtract off the white space, I'll be left with the area we're looking for. So setting up my integral, based on the drawing we just did, and I could verify it in my graphing calculator, but we know that the 2x squared is the function that is on top of the other one. So that goes first. And then you're going to subtract off the other function. So that is what we're going to be doing the integral of, and we already know that we're going from 2 to 3. So that gives us our limits. So quick doing the antiderivative of this, we end up with 2x cubed over 3 minus x squared over 2. And we're going to take that from 3 to 2. So first plugging in a 3, I get 3 cubed. So plug a 3 in here, I get 3 cubed, and then I am timesing that by 2/3. Make sure that your 2/3 is in parentheses. And then I'm going to subtract off essentially 9/2, so 4.5, and I'm going to be left with 13.5. Minus, again, this is just what happened when I plugged in a 3. Now I need to plug a 2 into everything and subtract off that amount. So 2/3 times 2 to the third, which happens to be 8, and then minus, if I plugged in a 2, I would have 4 over 2, which is 2. So minus 3.3 repeating. Gives me a total of about 10.16. So again, the area between the curve, not much different, only you're going to have a second function, and you just have to determine which one of these is actually on top of the other one, because that function comes first. So doing one more, and this time they gave me the two functions, but what they forgot to tell me is between what two numbers do they want me to integrate. And if that ever happens, what they want you to do is figure out where the two functions cross each other. So we're going to do another graph and just take a peek at this. We'll probably rely a little bit more on my calculator this time to help us graph it. The one equation is again a line. It has a slope of 1 and a y-intercept of -2. So up 1 over 1, up 1 over 1. Looks just like this. This is x minus 2. And then our other equation is a parabola. It's upside down with a y-intercept at 4. You could just graph this in your calculator and take a peek at it. And 1, 2, it hits there. And what I need to figure out is where these two hit each other over here. So I'm going to move over to my calculator, and I'm going to graph both of these. So negative x squared plus 4, and then my other equation is x minus 2. Giving them a sketch, there's my parabola, and there is my line. And I'm looking for where they touch each other, so I'm looking for the area that's just bounded between the two of them, so that space right there. What we can do is calculate, second calculate, and we're going to calculate an intersection. We want to know where they hit. Moving my cursor just left to right, moving my cursor over by the first intersection point, I'll hit enter, and it'll jump the cursor over to the second one, hit enter, and hit enter one more time on guess, and it'll tell you that they're intersecting at -3, -5. So 1, 2, 3, and because I didn't draw this very well, down there. So we're looking for all of that area right there. So we know that they touch at -3, -5, and our other point they touch at is 2, 0. And I'm going to do that again just to show you how to do the intersection again. So second, calculate. down to intersect. Put the cursor, just moving left and right, put the cursor close to the intersection, hit enter. The cursor jumped to the other line, hit enter, and hit enter one more time. And they are crossing, or they're touching each other at 2, 0. So those two x values are telling you from where to where. So I'm going to do the integral, the area between, from -3 over to +2. So as I make my integral sign, I'm going to go -3, +2. We still have to know which one of these functions is on top. It's pretty easy to tell from this one that the parabola is the one on top. So we're going to take that guy first, x squared plus 4, and then we're going to subtract off the other function. Watch your parentheses here. Make sure that you're subtracting off the whole function because that negative is going to need to distribute, and that can really adjust what you end up with for an answer. So in the end, we have -x squared minus x and then plus 6. Another way, just in case you don't have your calculator, another way to figure out where the 2 points that you're integrating between are is you can also set this guy equal to 0 and solve for x. So you could set the two functions equal to each other and solve for x. So bringing the x over here, I'd end up with x squared plus x, and then bringing that 4 over, I'd end up with -6, the exact opposite of what we have, so we're right. And then you could factor or quadratic formula this. By factoring it, you get that. And if you solved this, this would be x equals -3, and this one would be +2, which is exactly what we have. So you could use your calculator and do a second calculate and figure out the intersection of both of those. You could also set the two functions equal to each other and just solve for x, and that would also give you your 2 points that you're integrating between. So now we need our antiderivative. So -x cubed over 3 minus x squared over 2 plus 6x plus that c that we always keep along, and then going from 2 to -3. So first we'll plug in a 2. So I've got a -3rd here, or 2 to the 3rd and then divided by 3. Minus, plugging in a 2 here, I've got 4 over 2, which is just 2. And then here I've got 6 times 2, which is 12. So I end up with a 7.3 repeating. And then we're going to subtract off what would happen if I plugged in a -3. What you need to watch here is that you put -3 in parentheses excuse me, before you raise it to the 3rd power. Otherwise you're going to end up with the wrong sign in front. So we're going to end up with a 9 there. A -3 squared is 9, divided by 2 is 4.5. And then 6 times -3 is actually -18. So you end up with a -13.5 there. Watching your negatives again, because this will turn into a plus situation. And so taking our two values that we have and essentially adding them, I end up with 20.8 units squared of area between these two curves. So using the area between two curves, doing the integral, still have your numbers from where you're going to where you're going. You just need to figure out which function is on top, like visually on top of the other, because that function has to come first, and then you're going to subtract off the other function.